All right. Good evening, everyone. Or should I say it, good afternoon or good morning for those one that are joined for a different time zone. And first of all, thank you for joining. I like to say that people that actually join meetups, whether they're like person or maybe you're virtual like this, they're actually giving up a very precious time that could be with their families or doing something else, but they decided to be here to learn. So because of this, thank you very much. All right. We at Elastic, we feel very honored and appreciate this. So this presentation, whose title is kind of from zero to here with observability, there has some interesting story behind it. Like I'm gonna explain a little bit about before we jump into it, because the idea that I would like to share here today is to put more emphasis in the how part of how to handle observability. When I was first starting to kind of understand this word of observability, there's a lot of materials and resources and presentations out there that you can look up to understand a little bit more about the concept behind it, right? Which is not that complex. It's all about mining logs, metrics, and traces, and put that everything together in order to implement a very well-oiled machine for monitoring and observability, right? This is all the theory, at least, right? But every time you kind of trying to looking for some, okay, but how do I do this, right? That's the question that sometimes developers get so frustrated about not finding so many resources. And one thing is to look over the documentation of the product to understand how it works or how to put together. You're probably going to spend some hours, some weeks doing this. And another thing is to have a presentation that actually focus exactly on that. So this is what we're going to be doing this here today, right? I'm going to be building a observability stack, obviously using the Elastic stack, but I'm going to be building this from scratch, right? And we're going to use this to actually monitor a very small but very interesting application that I wrote using three different programming languages, which is Java, Golang, and Node.js, right? So this is what we're going to do today. For those of you that actually don't know me, and now I just realized that my counter had not started, so it just started. I have 44 minutes. My name is Ricardo, right? Like Yuli said, this is being my first official meetup presenting as a developer advocate for an Elastic, doing this meetup. I have a little bit of a background as a developer advocate for doing Kafka stuff in my previous companies. So I'm used to this, but this is going to be the first time delivering a presentation for on behalf of Elastic. So I'm very excited about it. I'm part of the community team, just like Yuli. We're part of this team that basically takes care of developers and communities, no matter if they're Elastic or some other technologies. And before Elastic, I used to work for other companies as well, for such as Confluent, which is where I used to work with Kafka, and then Oracle and Red Hat. And those are the technologies that I'm usually speaking on conferences and meetups, like streaming data, big data, NoSQL, cloud. Those are the kind of subjects that if you ever have some questions that I could help with, please feel free to get in touch with. Like those are my emails from Elastic and my personal email, as well as my blog, right? And for those of you that use Twitter, I put here on the bottom of the presentation my Twitter handle. So feel free to follow. Sometimes I put some useful content. Sometimes there will be jokes, right? But if you are into some very silly and IT nerd jokes, I think you're gonna like it, right? Okay, so that covers the me part. Before we jump into the gritty, needy details about the observability part, I would like to share something that's really, really important, which is the Elastic Contributor Program. I'm not sure how many of you have heard of, right? But this is a program, I'm not gonna like cover in too many details, but this is a program that Elastic created recently, which aims to recognize and reward the work that probably most of you are already doing, like during your free time. For example, when you write blog posts, when you help with documentation, or perhaps when you build a demo, or when you deliver and speak or organize a meetup. Those are the action that sometimes people do in the community, but somehow they don't see like, okay, I'm not feeling so much appreciated doing that. So this is a program that Elastic created that's going to help you with that, right? So what we want is to promote your work, right? So we're going to make your work actually getting more visibility within the community, which seems to be a good approach for your career. Like if you want to make your career like a being more, getting more traction. I think that's a good one. And also to get some prizes. So the plan for this program is to reward with some prizes for the people that actually contributes. And contributions can be different times. Like I said, when you were organizing a meetup like this, when you do the presentation or you collaborate with a presentation, producing reading content, blogs or articles or wherever you want to write about it, videos and code. In a nutshell, everything that you do, like I said, you usually are going to be doing it like anyways, right? So start doing this, but with Elastic backing you and making sure this is going to be visible and everybody can leverage on it. That's what community is all about, right? All right. This presentation, it won't have any more slides. This is literally my last slide from this. So I'm going to close the presentation, right? Because as I said, we're going to cover here the practical part about how to implement observability. So what I'm going to do, and we're going to build everything from scratch, okay? So what I'm going to do now is actually, where's my browser? I'm going to create an infrastructure on Elastic Cloud where I'm going to run everything related to Elastic, right? You could do this like in your machine, like you can download, install all the components, but I'm going to do this on purpose just to emphasize the fact that we're going to build from scratch. So I'm going to literally create a new deployment on Elastic Cloud, right? I'm going to call this Elastic Meetup. And I'm going to create this template for observability. And I'm going to select AWS and Virginia, which is my cloud provider and my region. Virginia, because I'm currently in North Carolina, so Virginia is going to be close to where I am, right? And as you can see here, I'm going to use the last version of Elastic, which is 7.10, okay? So I'm going to create this deployment, right? This creation usually takes around 3 to 5 minutes. Obviously, we're going to keep waiting here until that happens. So basically what I'm going to do is to download the credentials, which is kind of a dangerous, right? I just showed you my secret here of the password, but I'm going to destroy this environment anyway after the presentation. And while the environment is being created, right, I'm going to show you the application that we're going to use for to demonstrate what we're going to do here today. So first of all, before I even start showing any code, I'm going to put here on the chat the URL of the GitHub repo, okay? So everything that I'm going to do here today is on GitHub. Here's the link. So you can try it out in your machine. There's a Docker compose that basically spin up everything for you. You don't necessarily have to use Elastic Cloud for this, but if you choose to use Elastic Cloud, just like what I'm going to do here, it's going to work the same way, okay? So, okay, all right. So now that I've shared the URL, let's see the code. So basically this code is organized in 3 main folders, right? There is this front-end React, which is the front-end layer of the application that I've wrote using Node.js.
Ricardo, I'm sorry to interrupt.
Sure.
So you have to put to all panelists and attendees. I tried to copy your URL, but I cannot copy from the chat. So you have to
Got it.
to change to all panelists and attendees.
Thank you for the heads up. Let me
Of
know if
course.
it's working now.
Yeah, it did. Thanks.
That's a good point. I didn't ever pay attention about this. So panelists are different from attendees. That's a good point. All right, okay, good. All right. Okay, so with that said, so the front end React is basically written in Node.js. That front end actually accesses this backend that I wrote in Java. And this backend in Java has another backend, which I've wrote using Go, right? So the first question you might have is, why 3 different programming languages? Because in a real world, you're going to deal with different microservices, right? You're going to each microservices wrote in a different programming language. So it's good to emphasize the fact that observability doesn't have necessarily like a focus on a specific tribe or programming language, right? So we're going to use the 3 of them so you can see the difference between how you're going to instrument them individually. So let me do this. I'm going to actually start. I'm going to move to the folder to Golang and start. There's a script on each one of those folders that basically executes that microservices locally, as you can see here. So I've just executed the Golang, and then I'm going to use the backend Java, which I'm going to execute locally as well. I'm going to explain what the script does later when we cover the part of, okay, what's doing behind the scenes, okay? For now, let me just show the magic before the actual trick, right? So this is the backend Java already started. I'm going to create another terminal, and then I'm going to execute the front end React, which is basically the Node.js application, okay? So this application, obviously, I didn't bring anything like fancy here. It's basically a crude application for cars, right? So it's going to list cars. You can create new cars. You can delete the existing car and update new cars, right? So basic, for example, there's this car here, which is a Mustang, which is red. You can simply say that's black, and then you can save it. Basically, this is going to the front end, is going to create an API call to the backend, which is Java. And then this backend is going to execute against the database, which is an A2 database, is a local database for development purposes, but it can be anything, right? One thing that happens in this like application is that the backend service that's written in Golang also accesses a Redis cache that is running here locally on my machine. So you're going to see this after in the diagram that the architecture of this is really interesting, right? And the best part is that when you start building observability with this, there is a diagram that represents the entire architecture that actually expresses this whole topology, who accesses who, and basically is going to be detected automatically, right? So let me see if the cluster or deployment is already created. Yay, it is. Okay, cool. So as you can see here, I'm just created a new deployment on Elastic Cloud, right? This is being created out from scratch. So if I click here on Kibana, there will be nothing there, right? This is literally going to be empty in terms of, all right, there's no documents that are coming out of the middleware, right? So, okay, it's loading. Yeah, here we go. So this is the observability page, right, for this Kibana, which is an app. And as you can see here, there's nothing, right? There's nothing at all. If we go to the Discover tab to actually try to list anything from, here we go. There's no, as you can see here, there's no even any index pattern, right? So for those of you that know Elasticsearch, index patterns are basically how we're going to query data. So the ultimate proof that there is nothing here is that the fact there's no index pattern even created, right? So we're literally starting from scratch. So the first thing we're going to do here is to start with APM, right? APM is the acronym for Application Performance Monitoring, right? This is the part of observability that covers the traceability of applications, right? Personally, this is the most exciting part of observability for me, right? Obviously, logs and metrics has their value, but when you start tracing your applications, that's where you're going to actually start like putting a glue between all the services and microservices that you have in your architecture, right? And it might be like logical and simple for developers who wrote the application, but for whoever is responsible for the monitoring part, the ops team, the DevOps team, it might be not so obvious to understand the complexity that underlies the architecture. So that's why I think APM is very interesting for this. So the first thing we're going to do is go to the APM part. So as you can see here, there's absolutely nothing yet. So I'm just going to I'm not going to run the setup instructions, right? Everything. But if you would be like starting from scratch in your application, the first thing you have to do is to download or set up what we call agents, right? So agents are basically the components that are going to run locally or as a sidecar with your applications. And as the name implies, they're going to instrument your application, right? So the first step is obviously like pick up the technology that you were dealing with, for example, Java or Go or .NET. But as I mentioned before, I'm not going to run these instructions because I've created those scripts, remember, that I've showed before, that actually does this for me already. So what I'm actually going to do is to stop those applications. I'm going to stop the front end. I'm going to stop the backend Java, and I'm going to stop the backend and Go. And let's start with the backend Go, run locally. So as you can see here, basically what this script does is to export some environment variables, right? That's simple. And there's one here that basically sets the endpoint of my Redis cache, which runs locally on my machine. Actually, let me show you Redis first. So as you can see here, I have Redis running on my machine, and I have some caches already set for the cars that we're going to work with, right? So this is basically running on my machine locally. So this is the endpoint of Redis. So what I actually need to do here is to set this environment variable here, which you're going to pick this from here. Elastic Cloud gives you this automatically. So I'm going to copy this and set over here, as well as the token. Why do you need a token? Because there might be different applications running on your networks and pods and clusters. So this is a way for you to identify uniquely every application, right? You can create a secret token for each one of them. But in this case here, I'm going to be lazy and just use the same secret token for all the microservices, right? It's not a very good practice, but you got the point, right? And I'm going to actually copy this. I did this for Go. So I just did. So I'm going to run again, run locally. And then let's do the same for Java. So Java is a little bit different because of Java's architecture. But first of all, I'm going to export environment variables. And the reason why Java is different, because in a Java word, we have the concept of agents formally. It's different from Go, where the agent is actually a code that you write. I'm going to show the code later. But in Java, the instrumentation happens automatically. And all you have to do is to download the Elastic APM agent from Elastic. And then you're going to execute your jar file using the agent that comes from it, right? So this is basically what I'm doing here. So mine is Java agent. This is the agent. And this is the actual jar file that comprises my application, right? So with that said, I'm going to execute this again, run locally, right? The only difference is that this time, everything is going to be executed with the environment variable set. So now the agent knows how to contact Elastic APM, right? Because the endpoint has been set. And ultimately, I'm going to do this as well for the front end. The front end is a little bit different. So let me first set the variable, right? The front end, we don't need actually the token, okay? And why is different? Because the front end, as I mentioned, has been written using Node.js, right? Which is essentially JavaScript, okay? So this application runs within the browser, right? So the process that actually executes this application is the browser. So it's entirely on JavaScript. So all you have to do in your, let's call, JavaScript application is actually set this environment variable over here. And let me show you the actual file so you have to create this run.js file where you're going to do this. Basically, you're going to init APM, right? And you're going to pass the server URL as well as this is mine, right? This is basically to propagate all the context that has been instrumented by my JavaScript front end layer. And I want to propagate all this transaction to whatever backend I've set it here, right? And then you can ask me, Ricardo, where can I get this all information that you were telling me? So the good news is that everything is in here, right? I'm going to go back. If I click here, add data again, you see here's where it says run.js. Everything that I've just said to you is here. There's steps that you can follow that are basically going to show you how to do this, right? I'm just explaining for the sake of, right, I'm going to let me make it clear what are the actual steps, right? Now that I've just executed this, let me execute my front end again, run locally. And then I will actually run this using my host name, which is Ricardo. Okay. The application is essentially the same. In terms of behavior, the application will continue to do everything that has been programmed to do, which is create cars, delete cars, read cars, and update cars, right? The difference is this, my friends. Look at this. If I go to Observability Overview, you're going to see now, let me just close this because it's taking a little bit of the space of my screen. The difference now is that if you look here on, there's now a APM section that has been created here. Whoa, something's happening, right? So this APM session, if you click view an app, you're going to start seeing that, okay, there are services, or should I say microservices, that has been discovered automatically, right? Because I started, first of all, I executed them using the agents, right? That's the first step. And secondly, I've made some requests, right? By the time I came here and execute the application, first request, which is read all the cards, has been executed, right? This is a transaction, right? Because of this execution, right, the discovery part happens automatically. And if you click here on service map, that's the cool part, right? You're going to see that the entire architecture has been started to be discovered, right? What I mean by started to be discovered, because in here, there is an intrinsic relationship here between the front end, the backend Java. The backend Java actually calls the backend Golang. But as you can see here, there is no arrow connecting the backend Java and Golang. Why? Because so far, there has been no transactions that actually emphasize the fact of this relationship. But let's force one now, right? Which is basically, let's create a new car in this CRUD application, right? So we're going to create a Hyundai car. So it's going to be a Santa Fe, color beige, 2014, and the price is 3,200, right? I'm going to click save it. It's that simple. Basically, what happens behind the scenes is that the front end calls the backend in Java, and there's the estimate, right, that happens that basically the backend Java calls the backend Golang. Now, if I go back to the service map and click here, refresh, you're going to see that, oh, okay, so now the transaction has been fully discovered. So now the transaction has been observed by Elastic APM, and it was detected that, okay, there's a relationship here between the backend Java and Go, right? If you go back here in traces, right? So you can click here. I'm going to just dismiss here for now. If you click here on the front end, which is the first layer of our architecture, right? You're going to see that there will be the transaction types that you can like, okay, let me find more details about that transaction. So there will be one transaction called add car, right? And then if you click that transaction, it's going to bring you to this page where there will be some metrics about this transaction. And if you scroll down, look this beautiful piece of diagram, right? It basically shows all the details of that transactions, right? But more importantly, not from the point of view of one individual microservices, but from the point of view of all the microservices that has been involved on that transaction, right? So as you can see here, in other words, there was this transaction here. I'm not sure if you can see the colors, but the blue one represents the front end React. The green one is the backend Java. And I would dare to say that this color here is purple. I am actually terrible with color. So if it's not purple, please forgive me, right? But the purple one represents the Golang microservice, right? So as you can see here, the transaction started on the front end, and then it calls the operation save from the backend Java. And somewhere, I'm not sure you can see here, it's quite small because the execution of Golang was so fast. Technically, it took about 876 microseconds, which is less than 1 millisecond, right? That's why it's so small. But basically, let's call the green layer, which is Java, call the purple layer, which is Golang. And then there was some operations here. This represents the interaction with Redis, right? This two gets and the sysmember. And then after this execution finished, it went back to the green part, which is Java that calls a database. And one of the cool things about this is that if you click here on the insert into card operation, you actually can see the SQL statement that I was executed, right? Obviously, you can turn to not show this if you don't want it, right? Sometimes in production, this might be a good choice because it creates a less verbose transaction monitoring. But for debugging purposes, this is really cool, right? So if you're in a phase where you're still testing your applications on pre-production, this might be useful for troubleshooting purposes, right? But again, this is the beauty of APM, which is basically, oh, there's a question here from Yan. So Ricardo, how do you define the transaction types on APM? Example, add car. Yan, thank you for this question, because this is exactly what I'm gonna show next. So first of all, the definition of the transaction, let's call business transaction, right? The high level transaction, the genesis, the one that starts everything, usually has to be defined in the first layer that initiates the transaction. In our case, is the front end React, right? So, Yan, my friend, if you go back to the front end React over here, you're gonna see that we have, this is the front end React application, right? So in my application over here, where is, actually Carly's, I think. Here you go. So I have to change the names of my JavaScript files because they don't actually represent what I'm doing here. But anyway, this is a development problem, right? So there's this operation. This is a callback, right, that I've created here that actually executes when the browser initiates a new car. So as you can see here, I'm logging. And then there's this APM package here that has this method called start transaction. My friend, here is where I've defined the transaction, right? So how this transaction is kind of correlated with the other microservices, this is the magic, right? So depending on the technologies, there are different approaches to be used, but since this is JavaScript, everything that actually is kind of a special headers are inserted into the HTTP request, right? And that those headers are propagated downstream to whatever next microservice is going to be called. Remember when I've set this property here on my front end that basically represents my backend, right? So actually not here, sorry, here. This tag here says, okay, I should propagate which headers to which backend. So this is me telling, okay, whatever transaction has been started on my front end, I want to propagate this back to this backend. And what this backend is this 8080 port, which is my Java microservice, right? So whatever comes to the Java microservice comes already instrumented. That's the magic, right? So Yan, let me know if that answers your question, right? Otherwise, I can explain a little bit further. Yep, it is. And JavaScript is very, very intrusive. And you're going to see that in Go, it's basically the same way. But yes, you were right. In Java, it's way less intrusive because the Java, the instrumentation part happens automatically using the agent. Technically, what happens in Java is that we can add bytecode into the JVM automatically using the agent. So because this is not possible with JavaScript and Go, because they are the architecture of the programming language, that's why you have to kind of hard code your way through observability, right? But you're right in your comment about intrusive or not intrusive. Those perceptions are actually very important. So thank you, Yan, for bringing this up. Okay, so all right, so let me do this, and this is probably going to take a couple minutes, maybe more, but I think it's worth it to show it, right? So I'm going to create a new car, right? So as you can see here, this transaction took what, 151 milliseconds, which is fast if you think about it, right? But what I'm going to do now is actually create a new car. And in this new car, you're going to see that I've created intentionally a bug in this application. And this new car, because it's going to be a Ferrari, right, is going to take a little bit or more time. So let me create a new car. and I'm going to call this Ferrari. It's 2020 model, red, 2020, I don't know, 250,000. And I'm going to save it. Look, that's going to take about 1, 2, 3, 4, 5 seconds. Yay, 5 seconds. And then it works, right? The car has been created, right? But it took 5 seconds until the time the user actually started to the time that actually showed up in the application. So let's observe this transaction on Elastic APM. So let's go back here and refresh it. If we go back here again to the front end React, we can see all the transactions, one of them being the add car transaction. And you're going to see here now that we have 2 of those. Like, this is the first execution that took 151 milliseconds. But if you click here, this one took literally 5 seconds more, right? And this is the part where I think there is the huge value of tracings, right? Because here's the thing. If you don't have observability implement on your architecture, right, you're since the word is word, we always has been able to troubleshoot problems, and it may take some time, but the troubleshooting part is actually very easy by the time you know where the problem is, right? So in here, without observability, you would expend like a terrible amount of time, like tailing logs and watching metrics and SSH to a bunch of machines or pods or containers to actually try, not even to know, try to understand where the problem is occurring, right? And with observability, you can see there's like a zoom in your specific transaction that says, okay, without thinking too much, where do you think the problem is, right? So we can see this, all right, this is the high level transaction, so obviously going to take 5 seconds. But if you go down in the transaction stack, you're going to see that this whole 5 seconds started right here on this, let's call lag of the transaction called calculate estimate, okay? Because, why I'm telling you this? Because everything else that happened after this was pretty fast. For example, the 2 operations against Redis were fast, right? Like 86 microseconds. The operations with the database, they were all basically microseconds. But there was something happened on this calculate estimate. So let's take a look on this, right? But that's the interesting part. If you click it here, you're going to see, oh, okay, without looking too much, where the problem is. I'm going to look at here and say, oh, backend Golang. So that's where the problem is. So you jump straight to where the problem is. That's the value, right? Everything else, there has been like basically what we had to do to actually leverage this value, okay? So now, and sometimes you might even know the exact line of code that actually executed this. So let's go to the backend Golang to the line 109. So let's go back to the code, and I'm going to show the bug that I've created, right, intentionally. Okay, Golang, and then mango. So what is the line? 109. So let's go to the line 109, which is roughly this one over here. Okay, so let's recap. What is the lag of the transaction that took so time? Calculate estimate. Where this name is coming from. So this is one of the very interesting part about observability. As you can see here, forget about this for a second, okay? And let's concentrate only on this method. Actually, technically in Go, we don't call method, we call functions, right? Let's concentrate on this function call for a second, right? And then there is this function called calculate estimate. Basically, we receive it here, the brand, the model, and the year. And let's think about this. Something happened here on this method that it didn't happen before, because when we added the Santa Fe car before, it was very fast. So your first suspicious from this transaction is, okay, what was different here, right? So in order to give the people of operations the resources they need to figure that out, right, one of the things that developers need to do in their code is what I've done here, which is, you see where I create what we call here a span, okay? What I have been calling like the lag of the transaction, it has technically a name. It's called span, okay? So I've created a custom span here that I've called calculate estimate. This is why you're seeing this name over here. And if you click on this span, and if you go to the metadata tab, you're going to see that there are some labels that basically I've put some information there. And what labels are used for? Because this gave you hints for whoever is monitoring the system. Okay, oh, okay. So this span was dealing with a Ferrari with those, let's call parameters for now. It doesn't matter if it's a Ferrari or not, right? Okay, so with that said, I can actually go here to the function and troubleshoot this further, right? Okay, so, okay, this is a log, so nothing warm here. So basically what happened here is that I've established a connection with Redis, and then I executed a get operation. So that's what you're looking here. This is the get operation, right here. And then basically, if there was nothing recovered, I would do a second get operation, which didn't happen in this case, so we can jump it. And then I've calculated this we call markup price, which is basically a markup on top of the price from the car, right? Which is 5%, hypothetical, right? And then I am basically using this kind of okay, I'm executing this operation against Redis called sysmember, okay? So sysmember is to check whatever a certain item belongs to a cache. So let me actually show this on Redis. So I'm going to connect here on Redis. And as you can see here, there is a key that represents the, here we go, exotic cars, just like what I'm having here. Okay. So let's check the which members are part of the exotic car. Exotic cars. So those are the members. So every time there is a Lamborghini, I don't know how to pronounce this, or a Ferrari, or a Bugatti, or McLaren, or Mercedes, those are considered exotic cars. So if that's true, so what's going to happen is that, okay, is exotic is going to set to true, okay? So this is actually going to happen, right? So whatever is here was executed, and in the previous transaction, this is exotic was switched to false because the Santa Fe car from Hyundai is not an exotic car, right? So at least it's not here on the list. So that's why it was not exotic. So right off the bat, we can figure, okay, so you're telling me that in this transaction that was covering the Ferrari, this line of code here, which is a function, was executed. Oh yeah, that's basically what I'm telling you. And then if we investigate this function, oh, look what's happening over here. So back in my back in the days where I was doing full-time software engineering and working for consultancy companies back in Brazil, at least, we used to call this like dead cats, right? Like dead cats are basically those not so intuitive or efficient lines of code that sometimes we insert into the application that creates more damage than actually something helpful, right? So this is what we call a dead cat. So this is the source of our slowness, right? So obviously this was put here intentionally just to emphasize the troubleshooting exercise that I've just walked you through, of course. In the real world, it wouldn't be like a time.sleep, but it could be anything, right? It could be some other line of code that were not so efficient. Maybe the algorithm behind was not so optimized. So whatever was doing here is not very good. So what is the best practice for situations like this? I like to say that observability is not, okay, it is all about the ops team. It is all about the DevOps team. The developers have their responsibility too, right? So in order to make this troubleshooting exercise more simple next time, the best practice is to kind of make your code more observable, right? And how do you do this? With technologies like open tracing. So going back here to this, where I call it calculate estimate function. I didn't say this before, but what we are doing here is what we call open tracing, which is a open API. It has nothing to do with Elastic, right? Elastic is only compliant with this specification. And then you can use open tracing to demark your custom span. So in other words, what we should have done is this. We should have created a, there you go, a custom span for this line of code over here. So let's call it like my span, okay? This is no longer going to be part of the request. The context has been captured already because it has been passed as a parameter for us over here. And then after this, the execution of the markup, we can say my span dot end. Is this? Finish. End is Java. Here is finish. And I don't actually need to recover the context again. So I'm just going to ignore the context that is returned from this function, right? So, okay, in order to test this, okay, obviously, in order to test this, I need to actually stop my microservices in Golang and execute again, right? So the code can now leverage with what I just wrote in the code, right? And then what I'm going to do is, let me take one of those fancy cars here, like a Lamborghini. I'm going to copy, right? And I'm going to go back to my application and actually create a new car that's going to be a Lamborghini, right? All the parameters can be the same, maybe just changing the color for, like, I don't know, blue. It's going to be weird, a blue Lamborghini, but let's go with that, right? And I'm going to save it. And because is exotic car, is going to take, like, it took 5 seconds as expected. So it's working like expected. At least the bug is being repeatable, right? And let's go back to the transactions part, to the APM. So we can inspect that transaction again. So if you go back to add card, we should have 3 transactions. At least if we go back to last 30 minutes, yeah, we should have 3 transactions. So this was one of them, and this was another. Okay. Okay. I don't think this was this. Let's make sure which transaction is this. So this is a Ferrari. Okay. So it's not here yet. Okay, let me do this. For some reason, the transaction's not yet here. This is the part where troubleshooting should be interesting. Okay, there's 3 now. So there's 1 and 2. Oh, okay. I'm sorry. I need to, because I've just stopped it and started the Go microservice, I have to actually bounce all the services, not just the Go microservice. Sorry about that. But it's going to take only a minute to do this. This is the most interesting part. So I'm going to run again my Golang microservice. Oh, meanwhile, I just saw here that Yan made another question here about if you have an example of open telemetry. Yes, Yan, I've just created actually last week an example. After I finish here, I can show you this. And it works just fine. Yep, no worries. I created an example using Java and another one using Golang with open telemetry, which is pretty cool. Okay, I'm gonna run this again, and let me take again one of those fancy, not fancy, exotic cars. Where's the list of it? From Radis, a McLaren. Let's add a McLaren. 2020, white. 2020, I don't know, $300. All right, okay. It's gonna take 5 seconds as expected. And then we can go back to the transactions and inspect that again. Hopefully this new transaction will be showing up here. At least it should be, but anyway. Okay, you know what? I think this is about visualization. So for some reason, that transaction over there is not being shown. There's this one, and there's this one. Okay. So I'm not sure if I need to actually create a new time range here in order to detect that new transaction. So bear with me for a second. That's interesting. Okay. Good action transaction, you're looking to a distribution out of oh, yes, thank you. This, right? So probably there will be, right. But it's not showing, and this is the, okay. Let me go back to the front end transactions, and then let me go back to the button to actually come to the next one is disabled. For some reason, that's the part I'm not getting it. Oh, here we go. Sorry. I think now we can see it. Here we go. And then let's see which one is this. Okay, at least now we are seeing that the McLaren is here. That's good. Now, the part that we need to actually see it here is somewhere. Okay, oh, okay. It's here, but since we copy and pasted, it's shown under a different name. You see here, there's actually a span here with a different name, but since we copy and paste it in code, we didn't actually change it this, okay? We only changed the my variable. So that's what we should have done here in order to, because the name became the same, but you got the point. That's the interesting part. The point here is that we created a new span, and now it becomes clear to the operator or whoever is actually doing the troubleshooting part to what is the problem is, right? So good. All right. There is a question here from Carlos about having all this tracking in production cannot be detrimental to the response times expected by the end customer. So Carlos, not necessarily, because what happens is that whatever agent you're dealing with, whether if it's in Java, Go, or front end, the communication between the agent and the Elastic APM endpoint is, first of all, is asynchronous, right? There is also some buffering that happens. All the traces are actually buffered locally, and they're actually flushed to the Elastic APM asynchronously, right? So what I'm saying is because whatever transactions in the execution of your code that is actually happening to afford the business logic that you were expecting is going to continue to execute in the same time frame, right? So that obviously there will be a little bit of more footprint of resources that will be allocated, but in terms of performance, execution, or transaction latency, no, there will be no substantial changes in this matter, right? Because again, all the communications between the traces and the APM endpoint happens asynchronously, right? So that has been made intentionally exactly to don't compromise the performance of your transactions. So this was the answer for the question for Carlos Flores, right? Hope that answered your questions. Okay, good. So I think we have if we have 2 minutes, I would like to show you something really, really cool before we start wrapping up, which is for now, the only thing we have here is the APM part, right? we don't have any logs or metrics yet or uptime. So this is the part where Elastic offers what we call beats, right? Beats are the technologies that you can actually like harvest logs and metrics from your target endpoints or systems, and you can bring them into Elastic Observability that can be used to further correlate this whole troubleshooting exercise that we're doing it. So what we're going to do here now is let me open another visual code for my Elastic. I have here a Elastic. Okay, so I'm going to code 7.10. I'm going to use this to execute my beats. So I have here some beats that are installed on my machine, right? So let's start with the file beat first. And then the first thing you have to do is I'm going to go to the file beat. You have to execute the file beat, and you have to enable the modules that would like to start using it. So I'm going to enable the system module. So it's going to start harvesting all the system module logs, as well as whatever logs I've mentioned in the configuration file, right? So when you have a beat, everything that I have to do is to go here on this file beat.yaml file, right? And I put here already like the path where my logs for my microservices in Golang and Java are being created, right? I'm just going to uncomment them over here, right? And also, in order for the beat to send this data for my Elastic Stack, I had to set what we call the cloud ID, which is those two parameters over here. So where you get this? So if you go here to logs, for example, and you click or pretend to click on stall file beat, you're going to have like some templates here that you can follow. You can click in one of them because the only thing I'm actually interested here is to copy this. So Elastic gives you, right, all the information you need to perform this communication. So this is going to be the cloud ID, right? And the cloud authentication is the username Elastic with the password that when we created the deployment in the beginning, right, we've downloaded. So I've downloaded over here, probably, I have two files. So I'm going to dare to say that is going to be this one. And I'm going to copy the password of my Elasticsearch cluster and put it here. Here we go. And then all you have to do is to execute file beat once and run setup, right? What this is doing, right, basically is the setup part, you have to execute only once, right? So this is basically communicating with your Elastic Stack and instructing the Elastic Stack to upload indices, index patterns, the Kibana dashboards, the Kibana visualization, all the artifacts that you need in order to, in Kibana, to visualize the logs, right? So there's a whole pummeling that actually is happening here behind the scenes that is the result of this setup part. This is usually take up to 1 minute. So meanwhile, I'm going to check here in the chat to see if there's some questions or comments. Back to the transaction, that's it. And we can also apply sampling on production if the overhead isn't. Exactly, Yam, you're right. So what Yam's saying here is that sampling is basically controls the periodicity and the amount of samples from the traces that are collected that are going to be sent to Elastic APM. So in other words, if you feel that you are overwhelming too much, whatever microservices processes, you can kind of a ton with a knob on those sampling, right? So good one, Yam. Okay, good. So the setup part seems to be complete. So what I'm going to do now here is basically to execute my file beat with the parameter -e, which is basically outputs everything. So it's just start to mining everything. So if we go now and go to observability and overview, it should have a new app showing up there, which is the app for logs, right? Here we go. And then we have here, if we go click here on view app, there will be logs. Those are the logs coming from my machine, right? as well as the logs coming from those microservices. So in order to test this, I'm actually going to click here to stream live, right? And then I'm going to go back to my CRUD application and perform an operation, right? Because this operation is going to flush some logs, right? So I'm going to create a new car, right? This one I'm going to call test. Doesn't need to be fancy car. So it was pretty fast. And if you click it here now, we should have some logs coming up. We should at least. Here we go. So as you can see here, those are the logs that actually came from two services. The first one was the backend Java log. And also there's the log from the Golang microservices. So because again, when I've configured my beat, my file beat, I've told to basically take a look on whatever JSON files from coming from this Golang microservices as well as this file. So you can have multiple entries for whatever folders you want to monitor, right? So when you start doing this, the interesting part is that, let me stop the streaming. When you start doing this is that you now, Elastic APM kind of correlates everything when that happens, right? So by the time a trace is sent to the to Elastic APM, there's a piece of information that is inserted that automatically. The log happens the same thing, like whatever the sampling that results from the log, this piece of information ties together the logs and the traces. Why? Because if you go to APM now, and if you check one of the transactions, thanks again for the tip about how to find a transaction here. You can do this now, right? You can, like, let me find the last transaction, which is, oh, this one is fine, which is the recent one. And then you can click here on action. This is a transaction, right? You can click here on actions, and then you can trace logs. Basically, when you do this, you're gonna, it's like you would be checking the logs, but filtering for this specific trace over here, and voila, right? The logs that was collected from your host machines, right? Before being sent to Elasticsearch, some information was put in the log before the actual being recorded on Elasticsearch. And this is the beauty of Elastic APM because it correlates everything for you. So it makes simple to actually, okay, I'm going to jump from traces to logs, from logs to metrics, and vice versa, right? So this is one of the cool things about it. So Yam just started. So I'm going to stop here, right? I'm going to just answer questions because we're already on time. So Yam asked about the unified agent. Can you talk about this, please? Yeah. Yes, I can talk about it and already answer your comment. It is going to be way simpler with the unified agent. I didn't show here today. I wanted to, but it's still in beta. And I'm not a huge fan of showing things that are in beta. But in order to explain what a unified agent is for everybody that don't know what that is, let me put it this way, right? We've just configured the file beat, whose responsibility is to, like the name implies, to ship information about logs. But what about metrics? So in terms of metrics, you would use this metric beat over here. But what about like uptime? Uptime, you would have to have this heartbeat as well. So each beat has their own responsibility, which is fine. But for the operational perspective, there's a bunch of installation that you have to keep managing. So what Yam, hopefully I'm pronouncing your name correctly, Yam. Hopefully is Yam. So the unified agent that Yam mentioned here is basically one stall that you would put in your target machine. And instead of keep managing all those installation of different beats, the agent will treat each one of those beats as features that you can enable on, enable off. So, okay, I have an agent on a target machine that basically is configured to monitor file beats and metric beats. But audit beat, journal beat is all disabled, right? So this makes the life of whoever manages the beats much easier. But more importantly, the unified agent also has the concept of fleets, right? So what are fleets? Fleets are a way for you to create the representation of not one, but a bunch of agents, right, that can be like almost kind of atomically deployed on the target machines, right, with a predefined configuration. So you can define those fleets, right, on your Elastic, the Kibana UI, and then you can just, okay, so somewhere between the lines, you have to manually install the agent, right? You have to download and install it by yourself, right? But by the time you do this and execute the agent is going to actually pull all the configuration from the server and apply the configuration locally, right? So all those, everything that I've done here, like editing YAML files locally, you will no longer have to do this using unified agents. So, oh, thanks for the correction about your name. Yam, right? So yeah, so basically this is what the unified agent is about. Also, I remember that you've asked me about the open telemetry example. And as I promised, I'm going to share with you. I'm going to put here on the chat the links with the example that I've created for open telemetry, right? So those are very simple to follow examples. This one is for Java. And this one over here, let me go back. I've wrote one for Golang as well. So you can just, those are basically all the demos, those ones and the one that I've showed today, all of them has Docker Compose files. So in your machine, just Docker Compose up is going to pull all the images automatically. It's going to spin up all the containers and everything is pre-bundled, right? Which is cool if you are already know what they do behind the scenes, right? The value of the presentation today was to show the behind scenes about all the instrumentation part, right? For example, okay, how do I create a trace, right? So I've showed you, not this one, this one. How do I declare a trace? Like I'm showing you how to kind of create your own spans using open tracing, right? How do I instrument Java? Or okay, I've showed you how to execute your agent in your instrumented application, right? So all of this are the details that you have to know when you are actually implement observability by your own, right? When everything is set up and configured, is all beauty, right? As you can see here, right? Everything is simple and used to follow. But I think one of the values that are doing things like from scratch, as we've done here today, is to understand the actual effort for it. This is a habit that I've been using for a while now because developers would like to know and understand the complexities that are behind like observability. I think if I showed up here today with everything pre-done, you would say, okay, yeah, this is beautiful, but what is the complexity that is behind it? So I've just showed the actual complexity, right? So I think that's what I would like to show to you today, right? You're welcome for regarding the links. Does anyone has any more questions that you would like to know? I would like to open up for questions, like if you want it. Nope. What's coming in next in terms of features and observability? So actually it already came, right? Not sure if you followed, but there was this huge release, which is 7.10 that just happened recently. And let me show real quick. It's since we are using here the 7.10 release, you're going to be able to see this actually. One of those things, I'm going to give you two examples, right? I'm not going to take too much. Yeah, user experience, exactly. So user experience should be here already, right here, right? So user experience is a way to observability to see the interactions from the application from the user standpoint, right? So in order this to happen, right, certain things, as you can see here, the only thing that I have to do is to basically instrument. Okay, yeah. Basically what I have to do is instrument an application that was basically on JavaScript. So everything, it already detected here that my front end React is based on that because I was using run as the agent for it. So these metrics are calculated automatically for you, right? Another thing is what we call instrumentation syntax. This is something that if I had more time, I would like to show it here, but we don't have it today. But we can reserve this for our next meetup, maybe. Syntax, syntax instrumentations and monitoring is a way for you to, okay, one way to measure if the application is alive is to basically ping the endpoint. It works, but it's not necessarily useful if your application to be actually alive from the user perspective has to be some certain interactions going on. So you can actually script your way out to represent a whole flow or perhaps a whole transaction. And this script can be periodically executed against an endpoint to simulate if the application is actually alive. We call those syntax monitoring. And this is pretty cool. This is one of the things that actually we introduced recently for the observability stack. Another one is the PHP agent. So it's made available already. So for those of you that write programs on PHP, that's a way to go. What else? Searchable snapshot. So the searchable snapshots is a feature that has been introduced into Elasticsearch. But if you're leveraging observability from Elastic, you are actually going to be able to leverage that feature as well, which is pretty cool because think about this, right? We're just collecting like 1 hour and a half of metrics and traces and logs. But think about collecting all of this for 1 year or 2 years or 5 years. Where are going to put all of that data? It can be really expensive to store all that data on Elastic nodes. So with that feature in place, you can actually offload part of that data, historical data per se, to S3, right? Which is object storage. But instead of treating them as static DAD snapshots, those are going to be like searchable snapshots. So you can actually like simply, in other words, if you want to click here and say, okay, I'm going to want to see the last 2 years, the APM is going to bring this information from the snapshot and you can leverage without necessarily, okay, oh, first I need to stop, recover the snapshot, and then I can use it. So this is a cool thing about for observability. So thank you, everybody, for your time and your presence here today. Please take the time later on to fill out the survey that Yuli just posted here in the chat. And meanwhile, what is the license with searchable snapshot compared to frozen indices? So I don't know this for sure yet. I haven't tested it already, but I would assume that it would be basically the latest to, okay, imagine that you have an S3 bucket on AWS, for example, for how long it takes to actually like perform a GET operation into that, right? So on top of that, also put the amount of data that is trafficking across your network backbone. So I think all those variables are going to kind of influence the overall latency, right? Thank you, Carlos. So, but I honestly, I don't have like much metrics to share yet. I haven't tested any performance configuration about searchable snapshots. But I would assume that it's all about how much faster is your network between whatever the object store is from where the Elasticsearch cluster is running. All right, so Yuli, you want to close it up with some final words? That's okay. I can talk for you. No worries, no worries, no worries. And thanks everybody for being here today. Again, I appreciate your time because like I said in the beginning, you could be doing something else with your time, but you chose to be here today, sharing some information. So we appreciate that. And don't forget to think about participating for the Elastic Contributor Program. I think that's a very good way for you to show up your work. And there's a lot of content that you can build. And if you ever have some questions about how to build content, please just reach out to me or Yuli. We'll be more than glad to help you. And with that, have a nice day.